Good morning. We're very lucky this morning to have such a distinguished speaker. Dr. Craig Fischer, who is going to speak today, has held so many different positions in both the Army and the Air Force and NASA. It's just too long a list to talk about. But I'd like to basically just say he started at Kansas State and did his medical studies at the University of Kansas before he went into the Army. And he became a flight surgeon both in the Army and then later in the Air Force. After that, he served several tours, actually, with NASA, beginning, I guess, on Gemini 4, and then pretty much the Space Lab and everything after that, just recently retiring. He's also an AME. He's been a senior AME for the FAA. He's board certified in a number of things. Truly a impressive set of credentials. So we're very lucky to have him with us today, so I'd like to introduce Dr. Fischer.
Good morning. It's really a pleasure to stand before such an august group. Had such a lengthy training period that my wife didn't think I was ever going to get a job. But I finally did, and it was with NASA. And I was lucky to serve through most of the programs until 2007, actually. I still wish I was there. If I know that my retirement where I'd never done.
Hearing back here.
Can't hear! Can't hear!
He's in charge. The topic of this morning's talk is, as you see on the slide, loss of contact. Loss of contact meaning when we lost the Columbia. If you recall, in 2003, February 1st, the Columbia didn't make it through its reentry without disintegrating, killing all 7 crew. And so we're going to talk a little bit about it. It probably was one of the most detailed investigations of a vehicle accident that's ever taken place on the face of the earth. It required a tremendous effort over a 3-year period. So we're going to sort of encapsulate 3 years worth of stuff. Can we, this actually was onboard pictures of the crew during the reentry at the time of disintegration. And it's really very interesting to see, even during the time when there was, when the vehicle departed and went into loss of control, they were doing all the right things, right to the end, which was quite an amazing thing to see. Sorry you can't share that. As soon as the vehicle disintegrated, within hours there was a board appointed to look at the vehicle and what could have happened. And that was headed by an admiral of the Navy, and it was a very detailed investigation, but it did not address the crew and the crew cabin. Typical of engineers, you know, if you keep the vehicle in one piece, you don't have to worry about the crew. We worried about the crew, and so we formed a spacecraft crew survival investigation team, of which I was one of the leads. It wasn't a small team, as you can see, and this is just a part of them. It involved people from Johnson Space Center, Stanford University, Duke Tran from Boeing, who was one of the designers of Shuttle. And we had the FBI, of course. We had forensic experts from the Armed Forces Institute of Pathology, etc. So it was this slide is just to tell you that this was not a small investigation, and it wasn't just 1 or 2 folks. The investigation was enhanced by the fact that the Columbia was the first of the shuttle vehicles. And because it was an engineering first, they had it wired for sensors, unlike all the subsequent shuttles, because it was a test vehicle. So we had an advantage because we had a tremendous amount of data being transmitted to the ground because of the unique configuration of that particular vehicle. And the second thing we lucked out with was that the black box, which in NASA is called the MADS, was the black box, was recovered intact, which gave us information right to the very end. So those were the two advantages that the investigation had. Well, we had a really significant problem. Unlike an airplane, which can scatter over a couple of miles, we had debris that was scattered along the Columbia's course from Texas to Alabama. Because it, of course, is flying at 400,000 feet, Mach 25, when it started to disintegrate. So you can imagine the scatter. The furthest west debris was Littlefield, Texas. It started its disintegration probably just a little bit further west. 30,000 people were required. It took them 1.5 million hours to collect the debris. There were 37 helicopters involved, 7 fixed wings, and we lost 1 helicopter, unfortunately, during the 3 years of debris search. 700,000 acres were searched on foot, 1,600,000 acres searched from the air, and that would be equivalent to a 1.25 mile swath from Seattle to Boston. So you get the idea of the magnitude of this search. 83,800 pieces of debris were recovered. We had teams sitting there looking at the debris. People were bringing in raccoon crap, things that had no bearing on the accident. But amazingly enough, 83,800 pieces, 83,013 were actually bona fide pieces of the Columbia or the crew. Of the 84,900 pounds recovered, that would be 39% of the calculated vehicle dry weight. So that's an amazing thing, in my view, to be able to put that much together. With some of those debris pieces were, a couple inches in dimension. And 75 engineers and technicians worked 2 shifts, 6 days a week, while expending 144,000 person hours in the reconstruction in the hangar at Kennedy. 2,800 pieces were placed on a grid to get an idea of the grid. I'll show it to you. And it, as I said, it lasted for a couple of months, the collection period. And it was the largest such search ever carried out in the United States and probably in the world. Just to give you an idea of what we were faced with, you can see that's Texas on the left and Alabama on the right. And each of those dots represent the exact position of a segment of the vehicle or a crew mortal remains. So you can see that it was quite a... And the thing that was totally amazing to everyone is this stuff was raining down all over this track. Okay, some pieces as big as a car, some pieces as small as a bullet, coming in with a tremendous amount of energy, and not one person was hit. How you do that, I don't really know, but when you think about it, it's amazing to me anyway. This gives you a little bit of an idea how the search was conducted, because there's some water debris found, and you can see the way in which the crews marched. There was fire departments were used from local groups. There was a forestry department was utilized, the FBI, military, and of course NASA sent a bunch of troops out there too. So it was a tremendous effort. And here's a hangar at Cape Kennedy. Well, it just doesn't like that picture. And you can see they're putting the debris on a grid, trying to reconstruct the vehicle. And in the background here, you can see they're reconstructing the left wing. And you'll see in a few moments why that was the focus of the investigation. And it was this particular area here where the scenario started. We'll go through that. Crew, 7 people, commander and pilot. It's sort of interesting, there were 2 physicians aboard, and an Israeli pilot who was the commander of the flight that took out the Iraqi nuclear power plant back, what, about 15 years ago or so, I forget. So he was a very distinguished fighter pilot from Israel. You can see that they were all very experienced. Husband, who was the commander, 3,000 flight hours, 40 aircraft. McCool, who was, I love that name, Willie McCool. That was his name. Just a great guy. 2,800 hours, 24 aircraft, and goes on and on and on. And of course, Ilya Ramon, who was the Israelis, 4,000 hours in F-4s, F-16s, Mirage. And he was the one that participated in they call it Project Opera, which destroyed the Osrak nuclear reactor in 1981. So it was a very experienced crew. Their health was monitored, of course. They were all quite healthy, no issues. They were placed in protective quarantine prior to the flight, which was routine. That way they didn't have to deal with cardinal law, and they didn't have to worry about whether the kids were not going to school. And they also didn't catch colds. So we put them in quarantine to sort of give them a period of time to get ready. They flew to KSC, that's the launch site, on January 12th, and went to the pad on the 16th, and they boarded at 13:45 GMT. And the hatch was closed at 14:17, and everything was perfectly on schedule, no problems. With the vehicle or with the crew. STS-107, which is the flight designation, was the 113th flight of the shuttle, but the 28th flight of that particular vehicle, which is designated as OB-102. The launch took place right on time at 9:39 a.m. and cleared the tower, no problems at all. The initial seconds of powered flight were absolutely without any abnormality. But, 81.9 seconds mission elapse time. The video, and they take videos. That, a lot of times when they scrub for weather, it's not because the vehicle can't handle it. It's because they're worried about the optics of their cameras. They want to make sure that they get high-speed, high-resolution photos. And so a lot of times when you hear, well, the weather isn't up to speed, they're going to scrub. It's usually not the vehicle per se. It's more a monitoring system. But at 81.9 seconds, the post-flight video analysis showed a piece of insulating foam from the forward bipod area strike the underside of the left wing on the leading edge. Now the crew was unaware of this, of course. And here you can see a piece of foam here, a little piece of foam here, and you're just beginning to see a little bit of the debris from the piece of foam that's already hit the wing. The piece of foam was about the size of the briefcase. And here you can see very clearly debris from the foam strike. Now this was about the third day of the mission when this kind of analysis was available. The crew still had no knowledge of the strike. To give you an idea where that is, this is a picture. See, this is the bipod, and there's the foam, see it? That is the piece of foam that hit the left wing, and you can see how it just hit right about here. Here's a close-up of the foam. By the way, this was not the first strike. We'd had several strikes before, and so everybody was a little relaxed about it because we had had strikes that did not penetrate the carbon-carbon leading edge. So the facts were that the damage in the wing could not be seen from any location inside the crew cabin, and the crew remained unaware of the wing damage. And of course, in space, the orbiter performed satisfactorily. But on the 8th day, the Capcom, in the old days when they used to fly Mercury, they called it a capsule. The Capcom came from that era. It's really a spacecraft communicator, and it's always an astronaut. So the flight director always related to the astronaut who was the Capcom. The Capcom relayed an email stating that there was, quote, no concern for RCC or tile damage. And here is the actual communication which he sent. It was distributed to us in mission control. Key areas. They're sending this up only because the PAO event was scheduled and they didn't want to surprise the crew by having the press ask them about the foam strike, which they didn't know anything about. So it's just a heads up on the foam strike. And it said the impact appears to be totally on the lower surface. No particles are seen to traverse over the upper surface of the wing. Well, I don't know whether your eyes are different. My eyes, but I can see particles going over the top of the wing. So where that little phrase came from, I have no idea. Anyway, it said the experts have reviewed the high-speed photography and there is no concern for RCC damage. So right now, the organization is dismissing it. And because of their analysis, no change in the mission profile was found. Necessary or recommended, and the mission management team, which I was not a part of, because they made the decision to fly the mission as originally planned. There was a limited discussion with the CIA asking if they could use one of their satellites to get some high-resolution pictures of the wing. And the, quote, experts said, nah, it's too much trouble, we don't need to do that. And so there was no real concern going into the reentry. So after 16 days in orbit, the mission was accomplished without a hitch. And on 1 February 2003, the entry started. So this is a depiction of the flight deck. Flight deck, commander, pilot, and then the two crew. This is the crew engineer. Here you have this high-tech vehicle, and in order for her to hit some of the overhead switches, she used a stick. You know. So she sat here, and so 4 on the flight deck, and this is the mid deck, which is below the flight deck. There were 3 there. This person was in charge of some of the egress operations, should they be low enough and slow enough to bail. So this gives you an idea of how people were seated on the flight deck and the mid deck. Now you have to understand a phrase called EI. You'll hear EI used a lot. EI is the entry interface, when the vehicle first encounters resistance to the atmosphere. And that's a very critical moment, because up to that time, you could have holes in it all over the place, as long as the crew cabin was maintained pressurized. But once you start going into EI and below, you are now hitting the atmosphere. At 400,000 feet, it's just beginning to get dense enough so that you get some resistance. Above 400,000 feet, there's 1 molecule every 3 feet, so the altitude is 400,000 feet, and they were traveling at 24.5 Mach. And they were 4,400 miles from landing. It's 30 minutes. And we'll use GMP at 9:15, 30 seconds, which is 4 hours, 29 minutes before EI. Before EI, they started working their checklist for reentry. 2 hours before EI, or about 2 hours later, the commander entered the flight system command to initiate the pre-deorbit coast. Coast, 25 Mach 25 coast. And here's some just pictures of the crew. I randomly selected them. They're hard to see, but the parachutes and the seats were not deployed during the mission. They were stowed. But you can see that they've got everything ready to go. Seats are back in. Parachutes are where they should be. The escape pole, which happens to be moved, is in place, so everybody's going. They had done all the things that needed to be done for reentry. And here you can see them getting ready. Brown has his suit on. And you can see they're just working away and getting ready to go. Here you can see the commander's got his suit on. These are his legs. Okay? But he's heading up the tunnel to get to the flight deck to start the reentry. So everybody's working away, business as usual, no problems. And here they are in the office. There's the commander, there's the pilot. He's adjusting his G-suit setting. Notice that they don't have gloves on. Now, common sense would dictate that if you're wearing a pressure suit and you're at 400,000 feet, with a visor up and no gloves on, might as well be wearing your pajamas. But there's a reason for this. Again, it was an engineering constraint. But notice that they don't have their gloves on. Well, why? Because the dexterity of those gloves was such that they could not do all the switch throwing and the other tasks which they were required to do. So they would not wear their gloves during the reentry phase, and that, of course, is puzzling. Second thing is that notice their visors are up, and there's also a reason for that, and we'll go into it. So the commander at the EI, the commander asked, everybody suited, you know, yeah, we're suited. And, well, do a pressure check on your suit. And then let's go through a comm check, which they did. Visor down, gloves on, pressurize the suit, then take the gloves off, take the visor up, and we're ready to go. And actually, MS4, that's Mission Specialist 4, actually asked the commander if they were to keep their visor down, and he replied, no, and he was correct. That was the procedure, visor up. Why? Well, the Advanced Crew Escape Suit, which we call the ACES, was added after the shuttle cockpit was designed and built. Actually, it was actually a response to the previous Challenger that had disintegrated. And so the suit was upgraded. And as I said, in many cases, the crew could not use their gloves to throw switches, etc., so they used their gloves on. But last but not least, the mission rules dictated that the crew visors should be up during reentry to maintain low cabin O2. Because once they put their visor down, it activated their oxygen supply. And the oxygen, after it was into the suit, would be vented into the atmosphere. And the engineering safety officers felt that that would increase the PO2 of the cabin and would present a fire hazard. So now you've got a pressure suit on, you can't put your visor down, and you can't wear your gloves.
Okay.
So there's the suit. And there's one thing that I want you to focus on in this slide, and that is that it's a full pressure suit for intravehicular activity only, but it's down here, I don't know if you can see it. The primary life support is supplied by the vehicle, okay? The vehicle meaning the part of the spacecraft that's behind the crew quarters, okay? So if anything happens at that interface and breaks it, you're out of power, you're out of oxygen, you're out of everything. And we'll show you why that's important. And the backup life support, which was intrinsic in the suit, would only supply 10 minutes of oxygen, and you still had 25 minutes to go. So this is an engineering problem, which I'm sure has been addressed. I'm sure has been addressed. So here's the axis. 1344, they hit the entry interface, and 14 minutes later, all of a sudden, on the ground, the sensors in the left wheel well go off scale, which is highly unusual. Okay, so within 14 minutes after entry interface, the flight controllers knew that something was happening in the left wheel well. 52 seconds after that, loss of signal. So you see, you're talking about, at that point, 15 minutes after they hit interface, that things started going south. We then could reconstruct from the black box the fact that 5 seconds after we lost comm, that's when the yaw jets, they call them, up there you don't use aerodynamics, you use the various reaction controls to maintain the flight. And the left, the left jets kept firing, highly irregular. Usually you just have to pop them every once in a while to maintain the flight path, but there was something going on that was, the spacecraft wanted to yaw, and the jets were reacting to that yaw. So that's the only thing that the commander would have noticed. So in 15 minutes, there was a start of the departure from normal flight. 9 seconds after that, total loss of control. So you can see this is a 15 to 16 minute scenario from the time of reentry interface to the point where it was all over. During that period of time, when the vehicle was departing, the environment inside the cabin wasn't that bad from a G standpoint. This is x-axis, which is through, eyeballs down, and here's your y-axis and your z-axis. None of the G loads exceeded 3, and most of them were just 1 to half a G. So there was no problem with survivability in the cabin during a departure from a mechanical standpoint. And this gives you a little idea of what it was probably like, reconstructed again from the onboard computer. Here you can see the departure starting at 13:59:37, and at 13:59:46, 9 seconds later, this is the scenario. Here you can see that's when total loss of control. I had a picture clip here of the vehicle. You know, they reconstructed how it looked, and why did the vehicle lose control? That was the main thrust of the investigation from an engineering standpoint. Well, one of the things you have to understand is that this vehicle takes pictures of the vehicles, the spacecrafts during the reentry using infrared photography. And you can see that along the fuselage and the elevons, that purple is 3,000 degrees. So you have to know that there's a tremendous amount of heat on the leading edge of the elevons. They call them wings elevons. So with the strike, the tile was fractured and there was a hole, and now you can see how the heat could enter the wing, penetrate the bulkhead, and you can see the sensors were in this area here. And that's why they lost the signal for the left wheel roll. It showed it went off scale high. So in order to figure out why, a lot of the engineers said there's no way that beer cooler foam was going to penetrate the wing. There's no way. Yet they'd seen cracks before, but they just were adamant that there's no way that foam could have penetrated. So we had to sort of duplicate the situation on the ground. And so we got a segment of the actual, that's an actual piece of a shuttle wing. By the way, these are Russians. That's general. That's a United States general astronaut, but these guys are all Russians. Can you imagine? We had the Russians over to help them understand what happened. But we took a piece of the wing, and we took it to San Antonio, and this is a cannon that fires pieces of whatever against, say, canopies and windshields, or whatever you want to do. And they could duplicate the velocity, and they would load this thing with a piece of foam, and here you can see again. By the way, this is an aging cosmonaut. He had flown 4 missions for the Russians. So this is the cannon, and they fired it. And it actually, it's out of sequence. The hydraulics left the vehicle as well, but that's behind us, I'm sorry about that. The reason we know that they were doing their duty during the time they had lost control, and we'll get back to the mechanics of the wheeled car, is that we recovered a piece of the panel. This is obviously the cockpit, and you see this panel right here? We recovered it, and it was bent like this, so we know that nothing had happened to the switches, and we had found that Willie had thrown all of the switches necessary to restart the APUs, which had failed. So right to the end, he was able to do, even in that environment, do his necessary work. And the reason we know that he threw the switches is these switches require several operations to throw. One, you got to pull a switch out, then you got to throw it, and then come back in a detent. So there was no way you could just say, well, it was an arbitrary switch throw. I'd like to talk a little bit about the anatomy of the spacecraft. The spacecraft has a mid-body, has an empennage, and it has a forebody, which is composed of a crew cabin, that's the pressurized part of the vehicle, and then the external shell. This is the part, of course, that's most important to the crew, because that's their cabin. Knowing how it's put together, there's a link between here and here that holds the forebody to the mid-body. Well, 19 seconds after the APUs failed, the vehicle broke up, meaning that the forebody separated from the mid-body. And I'll show you a little bit about that. And when the forebody broke loose, it yawed left, pitched down, and the crew module shifted. And here's the link of the starboard side here, which shows tremendous degradation due to heat and shock-shock interaction. A concept which you in the audience who are physicists know much more about than I do. But the heat literally just melted that titanium fitting. And the port link was in better shape. To put it in perspective, those links were here and here. And so the forebody, once those links were broken, separated, yawed left and pitched down. They were still alive, still doing their work at this point. When that occurred, the module that contained the crew shifted inside of that outer shell. And when it shifted, it entered what's called volume E, which was outside the pressure vessel. And the reason we know that that occurred is that we found patches all along the course. And you can see when the first patch left at 1418 here, there were very few, and then it opened up and the patches were dispersed. So we know at that moment in time that the pressure vessel was penetrated and that a rapid depress was probable. I had actually clips of reconstructions of what the commander would have been seeing. And as it broke up. So once the forebody came away from the mid-body, okay, all fuel cell power was lost, so they had no power. All lighting, crew displays, radio, intercom, ventilation, all lost. And the main oxygen supply, which was behind them in the mid-body, was severed. So that was catastrophic. So as soon as the pressure vessel was penetrated, because we knew it had been because the patches were released, they experienced a rapid decompression. Now, we were all trained, right? In an aircraft, you have 10 seconds of useful consciousness. Well, when you're at that altitude, you have less than 3 seconds because you are becoming a donor. Everything is departing to the universe, and your blood boils because it's your 98 point, whatever your temperature happens to be at the moment. The vapor pressure of the blood at that temperature causes it to boil. So immediately your entire blood circulation has bubbles in it, so it stops. The second thing happens, your lungs rupture and they bleed. And the third thing is, obviously, now you don't get any oxygen to anything. So that was the cause of death at that moment. That's just a slide to show that we took a guess at the maximum hold, and we calculated the pressure drop. And you can see that within a couple of seconds, 3 to 4 seconds, they would have experienced pulmonary barrel trauma. Now, the mechanical injuries were of note because after the crew cabin separated, they still weren't in an environment that was violent enough to kill them. It wasn't until that hole developed in the cabin that they started getting into mechanical injuries, but they were clinically dead at that time. But you can see, if you look at the acceleration and G loading, it just climbed to infinity once it started coming apart. This is a close-up picture of the seats. My son was a naval aviator who flew helicopters, and that's a helicopter seat. That is not the seat you would expect in a high-performance vehicle or the shuttle. You can see it's a pretty spindly little seat. So the seats tore loose, obviously, and they had a 5-point harness, which was fine. You can see it here. But the inertial reels failed. Well, why did they fail? Well, because they didn't lock them. Because now one of the things you were trained to do is when the going got tough, you lock your inertial reel and pull you back in the seat. Well, they couldn't operate the vehicle and do their chores. They were snugged up against the, pardon me, the seat. So this 5-point harness was lax, okay? And the dorsal harness did not do any good, and the lower spine was being held by the seat, so you could get fractures like this. And all of them exhibited that kind of a fracture, because of course the torso is going forward and pelvis is held. And we duplicated, this is one of the engineers, we duplicated a lot of the potential strike zones later on. As you can see, there's plenty of room to get head trauma. And indeed, they had it. And they had a non-conformal helmet. You see it? your helmets probably when you flew military were conformal. They snugged up and you didn't rattle around in them. Well, this was not that kind of a helmet. As you can see, the head would be like that, and they can bounce around in there. And I want you to know there's this, because when I did the autopsies, I could find fractures exactly the same size and shape. It was that little piece of communication equipment. And of course, once they started breaking up, they had thermal injuries. And one of the zones where the cabin really opened up was right here next to the person sitting in seat 3. And she was severely injured and burned. And we reconstructed the burn patterns to see she was sitting here, and here's the penetration, and it was sort of forward and to the right. These reconstructions are amazing. It took only a couple of days for the IT group, to take the autopsy information and make the reconstructions. Down on the lower deck, of course, there were fewer burns because the heat entered the flight deck. So after complete breakup, you can see here this little puff. Can you see it? That's probably when the cabin was penetrated and the oxygen of the cabin was released, and it made the flame a little brighter. This is taken from a site, I think, in Texas. So they died of lung barrel trauma. They subsequently had severe burns, mechanical disruption, and flail, of course, once you're pitched out at that altitude and that speed. And when you hit the ground, of course, they had a real mechanical disruption. And that's just a summary of it. But the key here, and I have not, this presentation has been made many times, and it's not in total detail. In total detail after breakfast would not be too cool. But it's amazing to me. I have never had anybody from any of the aerospace corporations or from the FAA ask about, okay, now that you know what happened, what can we do about it? I'm assuming that they got the data some other way and will make the appropriate changes. But one change is that these inertial reels have to be secured, and that the seat has to be designed so that the crew, the harness, and the seat are in one unit, and probably not, a conventional aircraft configuration, if you're going to try to ameliorate that part of the problem. So they need to design the restraints have to be reevaluated and make it integral seat harness complex. Second thing, they were unprotected from vacuum. And if you got a pressure suit on, you wear the pressure suit. Otherwise, do what the Russians do. They did not wear pressure suits. And they lost 2 crews because of it. So if you're wearing a pressure suit, wear it. That means gloves, visor, etc. And they need to provide some kind of a system that's intrinsic in the suit, not dependent on the vehicle, to provide oxygen for the length of time that would be required. And last but not least, do you all know what the harness device is? That's the device that you wear a conformal helmet, and it permits you to move your head, but when it locks, it holds your head so that you can't flail it. Every race car driver uses one. As a matter of fact, that's a funny story. after we had these problems, we asked NASCAR to send 3 or 4 of their safety guys. Can you imagine, we got the Stanford, MIT, young engineers sitting around, and these 3 guys walk in. I mean, it was like the barroom scene in Star Wars. You know, and the first question they said is, well, how many G's are you guys worried about? And we said, well, about 25, 30. And they said, hell, we don't even worry about it until it gets to 200. And then they introduced us to the Hans device, because that would have really great. But it was sort of interesting to see the difference between the brilliant engineers and the safety guys from NASCAR. Everybody showed burns, and so we need to come up with some kind of a protective device. Suits are not going to do it. The suits were stripped off in a matter of seconds. It's going to be something like, remember the B-58 had a capsule, remember? It would, was the aardvark, the whole front end would come off. It's got to be something like that. And if you look at the Challenger accident and this accident, they both separated the forebody in one piece. So, with a spec, strap yourself in the seat, bust the front end off, and put a boot on the back, stabilize it, and then make it come in on a chute. It's probably the only way you could survive this. Because once the cabin is penetrated at altitude, you can survive it if your pressure suit's working, but you can't, take the mechanical forces and the other things of an uncontrolled reentry. So that's probably what you will see eventually if they ever have another winged vehicle. Remember, they've gone back to the Apollo vehicle, which is a whole different idea. So that basically is one of the first presentations, I guess, a public presentation of the accident calls from a crew standpoint. Sure. Questions?
If the crew had known about the damage after liftoff from the insulation, could that flight have been saved?
I suspect it could. They had another vehicle that they could have put on a pad.
Sorry, the question was if they had known about the damage immediately.
I'm sorry, I'll repeat it. Yeah, if the crew knew about it, crew knew about it, if the ground knew about it, etc., could we have salvaged the flight? Probably we'd have given it a shot, and the shot would have been to bring another vehicle, which was in the VAB, ready to be put on the pad. If we could do it, it'd probably take 3 days, and launch. And then you have to transport them from the injured vehicle over to the rescue vehicle. And we had a concept called a personal rescue sphere. It looked like a giant volleyball. And you put the person in the volleyball, you pump it up, and put a lanyard on them, and the astronaut in the EVA suit would take them over to the new vehicle and stick them in it. So we had the technology to do it. We never tried it, and it was a long shot. But any myths that you hear about, the people on the ground knew there was a hole there, they just didn't tell the crew, etc., is myth. Everybody, once they identified the fact that they had a strike, as you saw, they tried to analyze the data. And now, I don't know, the vehicle's not flying anymore, but in the later flights, they had the Canadian arm. You remember that big thing that they could, and they put a camera on it, and they go all over the vehicle, underneath and on the wings. And it's typical overkill, but nonetheless, now they have, or at least when the vehicle was flying, they had a method to analyze any damage. Yeah.
At the test site where you fired the cannon with the foam pieces, did it penetrate the test point?
Absolutely. By the way, did the foam penetrate when they fired it with the cannon? If the slides weren't out of sequence as they were, you would have seen that it did. It busted a really big hole in the carbon fiber of the wing. And so, yes, indeed.
I'm amazed at the fact that there was enough left of the bodies where you could do an autopsy on it after the traumatic.
Oh, yeah. It's amazing to me. Now, you know, sometimes the arm would be separated from the body, the leg, and but no, I left those pictures out. But yes, it was amazing to me. Now, the type of injury when you put them up in their seat positions, you know, when you looked at the gross photos, you could just about see where the vehicle was penetrated, who went out first, etc. Yeah, no, and not only that, but it's just amazing to me that they found all those parts.
What does the future look like?
Well, it's pretty dismal right now, I'd say, for the manned program. The unmanned program is making tremendous strides. He asked, what's the outlook like, and I assume you're in for the manned program? Pretty dismal. We only have one access to space, and that's the Russian vehicle, for which they are charging us $62 million a seat, and they let us take 3 people up a year, and the seat price keeps going up because they've got us. So the manned program is in extremis, actually. The unmanned program is going gangbusters. I mean, you're looking at pictures of Pluto. You're looking at close-up views of the universe in ways that we never dreamed possible. So the unmanned program is going great. The aviation, you see, most people don't realize NASA has a very big aviation program. They design the wings, they design the propulsion systems that are often used in industry. It's going well. But the manned space program, from the American point of view, is in extremis.
What, one more question?
Yeah.
Whatever became of the vehicle after it was put back together? Is it preserved somewhere?
Well, interesting. Yes, it's in that same hangar, being reconstructed. Yes, to answer your question, is what happened to all the parts? They're still in the hangar. They're preserved in 2 sections. One section is crew equipment, and the other section is the vehicle. And it's being maintained for posterity. You know what they did with Challenger? They put it in an unused silo, poured concrete over it, and it is gone. A very valuable piece of forensic evidence. But yeah, they say, I'll be here for a while if anybody's got any.
Thank you so much.
See you later. See you at the next one.
Good luck with your mechanic.
Walk around with that.
Every time there's a crash, there's quite a war going on. My knees were at one time sunk in the lake 20 years ago. The highest time ever was 32,000. And there are beavers out there now. Yeah, all my plants, most of them. I don't know nobody cares about if you would, forward that deal. You know, it's funny that it's positive feedback. Now, one of my buddies, you know, did write that, Charles wrote that, and I said, oh, shit, I wrote it one morning in like 3 hours, and added the pictures on my iPad and sent it out. You know? No one thinks you're a piece of shit. Yeah. So they said literary Johnny, that one comment in there about guys who are good with pins may not be as good a pilot. You know, I had to put that in there. But anyway, I've had some very positive feedback. There's guys want to use it in magazines.
I just talked to Jerry.
Okay.
I do a talk about a mid-air collision that I was involved in.